final presenter here, if not the final, Mr. Chandra. Okay. The title is Innovation in Precast Concrete Technology for Giant Seawall Construction in Indonesia. Literature review. Please.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Thank you very much for the MC, for the moderator, Mr. Fauzi. My name is Chandra Irawan with my partner Made Yujirus Semita, and from Civil Engineering Department ITS. Today I would like to present our literature review about the innovation in precast concrete technology for giant seawall construction in Indonesia. Next. Okay, during this presentation, I would like to divide into 4 parts. The first is our background, and the second is lesson from international presidents regarding with the seawall construction. And then the third is our proposed precast concept, and the last is the key recommendation for maybe for the government of Indonesia. Okay, for the backgrounds, as we know that in the Indonesia, especially in the northern Java coastline, face I think it is vulnerable increasingly, especially for tidal flooding. Maybe we know it as banjir rob, yeah, maybe tidal flooding, and then there is land subsidence and also the sea level rise. We have know about this case. So our government have a proposal, especially in the from President Prabowo regarding with the giant seawall or GSW project, starting from Banten to East Java, around 500 kilometers. So I think it is a very big project, yeah, in Indonesia, to solve the problem regarding with the Java coastline. And then the challenges is, the first is the feasibility, the next is the cost, ecological impacts, and then the last is the social acceptance. If we put a lot of concrete, yeah, in the coastline, I think this is the big problem. So we hope our government make a feasibility study and so on, yeah, better for this problem. Next. If we see in the international condition, international precedent about the coastal area protection, for example, in the Netherlands, we know that Netherlands, it is stated the land is below the sea level. We have know about it. So in the 1932, they produced like a dam that spirit from the sea area and the air tawar, yeah, to spirit with the seawater and the fresh water using this dam, yeah. The length of this dam, yeah, this wall is just around 32 kilometer. 32 kilometer. It is maybe, yeah, per 1%, yeah, from our project, yeah, that we conduct by our government. It is built in the 1932 during 5 years. So we can imagine if our government built the giant seawall in in the southern coastal of Java, maybe around 20 or 30 years later, it will already finish. In another side, in Japan, there is 395 kilometers tsunami barriers. We know that beside earthquake in Japan, also the potential disaster is tsunami. So the Japan government built tsunami barriers with long around 395 kilometers. and we can see in this picture. And then in another country like in Hong Kong and also in South Africa, they also produce the coastal, coastal protection to protect their lands from flood, from landslides and so on. And we see in this picture of using concrete, of using in bahasa in beton, ya, konstruksi beton, and to produce more better quality, almost they using precast concrete. So I will introduce, there are two types of concrete. The first is cast in situ concrete. It means beton yang dicor di tempat langsung begitu. And there is a precast concrete. So we produce in the factory and then we bring this product to the site and then install. Okay, next. There are some advantages of the precast system. Yeah, we can see in this figure. For the first is because it is produced in the factory, so we can control the quality. Yeah, if poor quality we install in the coastal, we know that there are a lot of loads that will damage the structure. For example, beban waves, yeah, beban gelombang, waves load, and so on, abrasion. So we have to ensure the quality of the concrete is good. One of the solutions is we produce in factory. And then the second, if we produce in the factory, we can control the strength, and then if the strength is enough, we can bring it to the site. So we can rapid installation. Okay, and then the next, because in the factory we can make everything this whatever the shape, whatever the size, we can produce in the factory. So, but the challenges if we use the concrete structures, we know that there is corrosion. Yeah, we have to know about this case. So beside these advantages, there are some challenges. Next, regarding with the corrosion, but in the concrete technology, we have some solution about this problem. For example, we can use a special cement that it will be sulfate resistant cement maybe. Okay, in another side we can use some supplementary material, for example slag, then fly ash, so we can produce a good quality of concrete. Maybe another solution, we can use protective coating, yeah, and then corrosion inhibitor and so on. Or because the corrosion, it is the process if we use the reinforcement from steel, so we can change from steel become maybe a fiber reinforcement for the concrete. Next, for the shape of the giant seawall, there is some reference that we can use. For the first is using modular precast pile. Precast pile in bahasa is tiang pancang, ya. We can use tiang pancang, or we can use sheet pile. Yeah. Usually tiang pancang the shape is round, but the sheet pile is like paper, yeah, that we put. Maybe we can see in Hang Tuah, yeah, near our campus, there are some sheet pile that put beside the Jalan Arif Rahman Hakim, and then we make balok a beam in the top. So in the picture A, yeah, so it can resist the water from the sea that can make abrasion to the coastal area. Okay, another shape we can use like this one. Yeah, there is vertical panels, but the important one, we can use also the reinforced armor unit. Armor unit is like tetrapod, hexalog, and so on. So we can reduce the energy from the waves from the sea. So when it breaks to the land, it is not dangerous for the land. And also to reduce the waves from the sea, we can using the perforated or cellular element. We produce a hole in the wall, so the energy from the waves it reduced. On another, we can hybrid, using maybe mangrove. Yeah, we have know about mangrove. So, but according to our experience, when we visit to mangrove, di mana itu ya, okay, it is difficult to plant mangrove, especially in Surabaya. Next. And then the next is the implementary strategy for the precast. Maybe we can make pilot projects, maybe not 100 kilometers, but just 1 or until 3 kilometers first. And then we validate the design. I mean, it is effective or not, yeah, the design. And then regarding with logistic, because the precast concrete is produced from the factory to the site, we can calculate regarding with the cost and so on. And also we can also using the local precast supply chains. It means that maybe if we have a project in Gresik, maybe we can produce the precast element in Gresik. If we have project in Pekalongan, in Semarang and so on, we can produce near the location of the project. So maybe it is more effective, yeah, regarding the cost. And also we can use another instrument. For example, if we can use heavy lift parts and also roll off or logistic, it means we use special ship to bring this element to the sea. Okay, and regarding with the social impact, yeah, we know that there are absolutely there are many problems, especially for the nelayan, yeah, and then for the people that around the coastal area, maybe it become a problem. So we have to, maybe we can conduct the community engagement or GS program for social acceptance. Next. So according to this explanation, we can make benefits, yeah, using the precast concrete, yeah, we can accelerate our construction time, and also we can obtain good quality control and also reduce the maintenance for our structure. But for the trade-off, or maybe because it is produced in the factory, maybe the high initial investment. Yeah, we have to produce the molding. We have to make the factory. So it is a high cost initial. Okay, so we have to integrate the planning and stakeholder engagement between the contractor and the government and so on. Next. Sustainability and SDG alignment. Yeah, if we use the precast element, absolutely we can it is aligned with the SDG 11. Yeah, protect the coastal communities, regarding with the sustainable cities, and then resilient infrastructure, innovation industry, and then the last, if we use a hybrid system, it will hybrid nature engineering life below water. It is safe for the animal that live in the sea. Okay, next. So according to this literature study, based on this data, we propose that precast concrete, it is the backbone for the giant seawall, because we can produce more effective, yeah, put in time and also the cost. Because our concrete is in a good condition, we can obtain a durable reinforced concrete structure, yeah. So it will minimize the maintenance cost. Maybe for the first, we can make pilot projects, maybe some kilometer we produce and we analyze the condition. And also regarding the ecosystem or the ecological aspect, we can use ecosystem-based measure. We can combine between the natural coastal protection using mangrove and so on. Yeah. Okay, and the last, maybe we can starting research the local materials and lifetime impacts needed regarding with this proposal. Next. Okay, thank you very much.
Okay, nice, great presentation by Mr. Chandra. Is there any question? Anybody here? Please, Ms. Lily.
Thank you, Dr. I want to know this material to fabricate the precast concrete. The material, one of them is the fiber to change stainless steel. Is the mechanical strength like stainless steel? This fiber. So, and the second is what the raw material to fabricate the fiber, because if I am from chemistry, so I want to know the raw material to synthesis the fiber.
Okay, thank you very much. As we know that usually if we would like to produce a concrete element, for example, span pipe, tiang pancang, we will make a caging of reinforcement. Kita akan buat rakitan besi tulangan and then we pour the concrete. Kemudian kita mengecor beton tersebut. But the risk is regarding with the corrosion. If there is a cracking, maybe in the natural condition during maybe 40 or 50 years later, it will be corroded. Yeah, because the concrete is produced using precast with better compressive strength, better permeability, so we can make a longer lifetime of this structure. But another problem regarding with corrosion, we can make solution using fiber. As a civil engineer, we also user for this material, so we don't know about how to produce this material. But I can explain. There are some types of the fiber, maybe like a stainless steel. It is like benang, maybe like a benang in the spatial dimension, short dimension, we pour in the concrete. So if we put this material, the concrete is stronger than the conventional stronger. There are also another type of the material for the fiber is using FRP, maybe fiber reinforced glass fiber. Yeah, CFRP, carbon fiber. Carbon fiber, I think. Carbon fiber, glass fiber. There is steel also, but still usually it's coated by like aluminum, maybe. Because we are using maybe. Yeah, to resist the corrosion process, like that. So it is maybe interesting to, because the price is high. It is the chance for us to reduce the price, because we know that it is a big project. So it is a good opportunity for us. Thank you.
Okay, very good. You have a question, please?
Thank you, Mr. Chandra, for the great presentation. So I want to ask about in every island, in every area, we knew that there is difference in their soil. When you mentioned before tiang pancang for the gas, and is there any impact for the soil from this tiang pancang, and also is building the giant seawall itself is a long-term good decision for environment? And maybe that's all questions for me. Thank you.
Thank you from Ms. Belfan. Okay, according to my experience during these topics, actually in ITS it is also topik yang sedang hangat regarding with the giant seawall. beside ITB, ITS also conduct the feasibility study about this case. There is a pro and also contra regarding with the giant seawall. We can imagine when we have a vacation to the beach, but the beach is lined by concrete wall. We can imagine like that. So the most ecological low impact, according to our study, is we have to make a wise solution yang bijak, where we will put span pile foundation, where we have to make mangrove, when we have to tetrapod and so on. So for along 500 kilometer coastal area, there are a lot of or partial feasibility study maybe, I think. So maybe in Lamongan it is appropriate using this type. In Gresik appropriate this type. But for this structure, using span belt, almost a lot of area in Jakarta using this type, because in Jakarta the type of soil is soft soil, I think, because it is tanah endapan kalau di Jakarta. So a lot of project using span belt. But if we see in Gresik, in Tuban, there are a lot of reef. So it is, I think, impossible if we use tiang pancang. Maybe better we can use tetrapod and so on. So better area, better solution for giant seawall. So we have to know giant seawall is not like dinding. No. Giant seawall is coastal protection. So we have to make a spatial feasibility study, spatial feasibility according to the area and the condition of the coastal area. Thank you.
Okay, very interesting disciplines. Any question? Any other question for our presenter? Okay, so that's our final presenter. Give applause to Mr. Chandra. And that's our final presenter. So I have to conclude this session today. So we have a highly informative session today.